It travels at the speed of light, which means you wouldn't see it coming. You wouldn't hear a warning siren. You wouldn't even have time to blink. One moment you are walking down the street, looking up at a clear blue sky. The next moment, the atmosphere is on fire. The ozone layer, our planet's shield, is instantly vaporized. The sky turns a blinding, violent violet. And then, silence. This isn't a scene from a sci-fi movie. This is a scientific reality. It is the most violent, most powerful event in the known universe since the Big Bang itself. It is called a gamma-ray burst. And right now, as you watch this video, there is a star system less than 8,000 light years away aiming directly at us like a sniper rifle. Most people fear asteroids. We spend billions of dollars tracking rocks in space because we think we can deflect them. But you cannot deflect the beam of pure energy. You cannot hide from it. And if one hits us, history won't just change, it will end. So what exactly is this cosmic monster? Why haven't you heard more about it? And most importantly, how much time do we have left before the trigger is pulled? To understand a gamma-ray burst, or GRB, you have to understand the scale of energy we are talking about. The human brain is not designed to comprehend these numbers, but let's try. Imagine our sun. It is a massive nuclear fusion reactor. It has been burning for nearly 5 billion years, and it will burn for another 5 billion. That is a lot of energy. Now, imagine taking every single bit of energy the sun will create in its entire 10 billion year lifetime and releasing it all in 10 seconds. That is a gamma-ray burst. It is a focused beam of electromagnetic radiation of the highest possible frequency. It usually happens when a massive star, one that is dozens of times heavier than our sun, reaches the end of its life. When a normal star dies, it might explode into a supernova. That's violent, sure. But when a hypermassive star dies, its core collapses into a black hole. But it doesn't just collapse quietly. The infalling gas gets superheated, swirling around the newborn black hole. Magnetic fields twist and turn, launching two jets of high-energy particles out of the poles at 99.99% the speed of light. Think of a supernova like a light bulb turning on in a dark room. It sends light in all directions. It's bright, but the energy is spread out. A gamma-ray burst is like taking that same power and focusing it into a laser pointer. If you are not in the path of the beam, you might just see a pretty light show in the distance. But if you are in the path of the beam, well, that is where the nightmare begins. And the scary part is, we've been hit before. Let's travel back in time, 450 million years ago, the Ordovician period. Earth looked very different. There were no dinosaurs yet, no trees. Most life lived in the oceans. It was a thriving, biological paradise. And then suddenly, 85% of all species on the planet vanished. Paleontologists call it the Ordovician-Silurian extinction event. It is one of the big 5 mass extinctions in Earth's history. For decades, scientists were baffled. There was no giant crater like the one that killed the dinosaurs. There was no evidence of a massive volcanic eruption. The planet just died. An ice age began instantly. Today, the leading theory is terrifyingly simple. A gamma-ray burst originating from a star 6,000 light years away struck Earth. It didn't fry the surface instantly. It did something worse. The gamma rays slammed into our atmosphere, shattering the nitrogen and oxygen atoms. This created a thick smog of nitrogen dioxide, essentially a blanket of dark gas that blocked out the sun. The planet plunged into darkness and cold. The ozone layer was obliterated, letting in deadly UV radiation from the sun. So, the life that didn't freeze to death in the dark was cooked by radiation when the smog cleared. It was a double-tap execution. If it happened then, statistically, it is guaranteed to happen again. The galaxy is a shooting gallery, and Earth is just a floating duck. And the gun? We know exactly where it is. Look at the constellation Sagittarius. Deep in that spiral of stars lies a binary system called WR-104. It is beautiful. If you look at photos from the Keck telescope, it looks like a perfect, glowing pinwheel spinning in the dark. But that spiral is a warning. WR-104 contains two stars orbiting each other. One of them is a Wolf-Rayet star. This is a star in the final, most unstable phase of its life. It is rapidly shedding its outer layers, preparing to die. And when it dies, it is the perfect candidate to trigger a gamma-ray burst. But here's the problem. Remember the laser pointer analogy? A gamma-ray burst is only dangerous if the gun is pointed at you. For years, astronomers tried to calculate the angle of WR-104. If the pole of the star is tilted away from us, we are safe. We would see a bright flash, but we would live. However, recent spectroscopic data suggests something chilling. The angle of the system is nearly 0 degrees relative to Earth. That means we're looking right down the barrel. The pinwheel we see is face on. The gun is loaded, the safety is off, and it is pointing directly at our solar system. Now, critics will say, WR-104 is 8,000 light years away. Maybe the beam will widen and lose power before it hits us. That is wishful thinking. Gamma-ray bursts are so focused that even across 8,000 light years, the beam would still be tight enough to encompass the entire solar system. There is no dodging it. And the worst part? WR-104 is unstable. It could explode tomorrow. It could explode in 100,000 years. Or, because light takes 8,000 years to travel to us, it might have already exploded 7,999 years ago. The death beam could be crossing the final mile of the marathon right now, approaching Earth's orbit while we sit here arguing about politics and the weather. Let's play out the scenario. Let's say the beam from WR-104 arrives today, right now. The first sign would be a flash of blue light in the sky, brighter than the sun. It doesn't matter if it's night or day. If it hits the day side, the sun will look dim by comparison. If it hits the night side, the darkness will be torn apart by a light so intense it would blind anyone looking up. Satellites would be the first casualties. Every communication satellite, GPS system, and space telescope would be fried instantly by the electromagnetic pulse. The internet goes down, phones go dead. Power grids across the hemisphere facing the burst would overload and explode. But the loss of TikTok is the least of your problems. As the gamma rays hit the upper atmosphere, the air itself begins to glow. The radiation breaks apart the chemical bonds of the air we breathe. The ozone layer, the only thing protecting our DNA from the sun's cancer-causing UV rays, is instantly destroyed, gone. For those on the surface, if you weren't blinded by the flash, you would feel a sudden wave of heat. But the immediate radiation hitting the ground might not kill everyone instantly. The atmosphere is thick enough to absorb some of the initial X-rays. The real horror starts in the days following. With the ozone layer gone, the sun becomes our enemy. Anyone stepping outside without a heavy hazmat suit would receive a lethal dose of solar radiation within minutes. Plants would begin to die within days. The crops that feed the world, wheat, rice, corn, would wither. Then comes the cosmic winter. The chemical reaction in the atmosphere creates a dark brown smog of nitrogen dioxide that wraps around the planet. It blocks the sunlight. Temperatures plummet. Acid rain, literal nitric acid, would fall from the sky, poisoning the oceans and killing the plankton that produce most of our oxygen. The food chain collapses from the bottom up. Starvation, cold, radiation sickness. Civilization wouldn't just crumble, it would be erased. And unlike a nuclear war where we might hide in bunkers and wait for the fallout to clear, this damage takes decades, maybe centuries, to repair. This brings us to a terrifying question. The Fermi Paradox asks, where is everybody? There are billions of stars, billions of planets. Life should be everywhere, yet we hear nothing. We see no ships, no signals, just silence. Maybe gamma ray bursts are the reason why. Some scientists call it the Great Filter. The idea is that maybe life starts all the time across the universe. Maybe civilizations rise, build cities, and dream of the stars. But then a random star a few thousand light years away collapses. Zap, reset. Maybe the universe is a self-sterilizing system. Maybe enhancing life is like a bacteria culture in a petri dish. And gamma ray bursts are the UV light that keeps wiping the slate clean before anyone gets too advanced. It makes you realize something profound. We often think of space as this majestic, beautiful frontier waiting for us to explore it. We look at the stars and feel hope. But space is not our front. It is a violent, chaotic, and indifferent ocean. And we are floating on a tiny raft with no engine in the middle of a storm we cannot control. So, should you stop sleeping? Should you spend your life looking up at Sagittarius in fear? No. Because there is another way to look at this. The fact that you are here, breathing, thinking, and watching this video is a statistical miracle. Earth has dodged these cosmic bullets for 450 million years. We have survived ice ages, asteroids, and volcanoes. We are walking a tightrope over an infinite abyss, and somehow we haven't fallen yet. The existence of gamma ray bursts shouldn't make you depressed. It should make you value the fragility of this moment. Every day that the sky remains blue, every day that the sun warms your face instead of burning it, is a gift. The universe is a dangerous place, but that is exactly what makes our little, fragile oasis so incredibly special. If you enjoyed this journey into the dark side of the cosmos, make sure to hit that subscribe button. We have many more nightmares to explore together. Until next time, keep looking up. But maybe don't look too closely at WR114.